Okay, so for 4 letter C, doing the same thing with the Taylor expansion, we have our most complicated function so far, x squared over root 2 plus x, and our a is equal to 0, so this is actually going to be a Maclaurin expansion. So, let's use our Taylor series formula. First term is just going to be plugging in 0 to our function, but if you plug in 0 to the function, you get 0. So our first term is going to be 0. So our second term, we're going to need to take the derivative of this and plug in 0. So to do the derivative of this, we're going to have to do quotient rule. So for f prime, so remember for quotient rule, we get the derivative of the top times the bottom. So we get 2x. I'm going to write these roots as half powers instead. Minus the derivative of the bottom times the top. So here we're going to get 1/2 2 plus x to the negative 1/2 times the top, which was x squared, all over the bottom squared, which is just 2 plus x. We're going to need to simplify that before we do the second derivative, but let's look at the plugging in 0 right now. And I mean, if you're plugging in a number, there's not much point in simplifying. You only want to simplify if you're going to have to take another derivative, which we are going to, but let's try the number first. We're plugging in 0 to the derivative. You can see here, this is going to be 0, this is going to be 0 over 2, so we're going to get 0 again. So actually our second term is also 0 times x minus 0, which would still be 0. So for our third term, we're going to need the second derivative. So the best thing to do here would be to consolidate this as much as possible. Since we have a 2 plus x to the 1/2 and a 2 plus x to the negative 1/2, it would make the most sense to multiply top and bottom by 2 plus x to the 1/2. That would get rid of this fraction, since that has a negative power. Okay, if we do that, the first term would become 2x times 2 plus x, because we get 2 plus x to the 1/2, 2 plus x to the 1/2. That would just get rid of the root. The second term, these would cancel out completely, and we just get half x squared. And on the bottom, 2 plus x to the 1 times 2 plus x to the 1/2 would be 2 plus x to the 3/2. So there's our derivative. Maybe not as simplified as possible, because we could still expand this too. So let me just work with the numerator. Our numerator is going to be 4x plus 2x squared minus 1/2 x squared by distributing this 2x through. And 2x squared minus 1/2 x squared would be 3/2 x squared. So our final simplified version of the first derivative is 4x plus 3/2 x squared all over 2 plus x to the 3/2. So there's our first derivative, as simplified as possible. Now we can take the second derivative. And you might be thinking, okay, this is crazy, taking the derivative of this again. However, keep in mind, since we were only asked for the first 3 terms, not only is this the last one we're going to have to do anyway, but we're not even going to have to simplify it, because we're just plugging in 0. So you're not going to have to rearrange and do all this algebra again. Once you take the derivative of this, you can leave it in whatever gross form it starts with. So let's take the derivative here. So again, we have to use quotient rule. So the derivative of the top is 4 plus 3x. 4 plus, this would be, bring 2 down, they would cancel, lower the power by 1. Times the bottom, minus, let me scoot all this over so we have space. So we're going to get 4 plus 3x times the bottom, 2 plus x to the 3/2, minus the derivative of the bottom. The derivative of the bottom would be 3/2 2 plus x to the 1/2 times the entire top. All over the bottom squared. When you have a power of 3/2 and you square it, you would just get 3 then. So that's using quotient rule on that. Again, we don't have to simplify any of that though, because we're only interested in what happens when we plug in 0. So if you plug in 0, this disappears, that disappears, this disappears, and both of those disappear. Meaning, if this whole term is 0, this whole thing becomes 0. So that goes away. And what do we get? We have 4 times 2 to the 3 halves is the square root of 8. We have 4 square root of 8. On the bottom, we have 2 cubed, which is 8. And because this whole second part of the numerator ended up being 0 anyway. And that can be reduced, of course, to square root of 8 over 2. So our first 3 terms here, we need a couple other things here. That's just the second derivative at 0. Then we would have x squared, because a is 0, so x minus 0 squared, over 2 factorial, which is just 2. So finally that last term becomes square root of 8x squared over 4. So our first 3 terms are 0. Write that out a little bit more clearly. Square root of 8x squared over 4. So our first 3 terms are 0, 0, square root of 8x squared over 4 by using the Taylor expansion.